This is my reassessment for work energy, and this is my energy right here plus the width plus the friction right here, and then I know that the formula right here is 1/2, and I put m in the KD signs for the kids for the problem, and then the vector to the second square, then I close parentheses and I put plus, and I put J to represent Joe in the problem. And when you draw it up, it's going to equal cosine 30 times the direction minus the friction, and then it equals 1/2. 1/2 comes from right here, 1/2, and then MKD again. That represents kids, the KD, the vector to the second power with the friction right there. And then when you write down all this, the J cosine 30 minus friction, that equals the net force times D. That can equal net force. That can help you whenever. And then I end up just rewriting pretty much everything down here to make it a little bit neater though. Like I just move friction like inside parentheses. I just put D outside the parentheses to times it. And then I end up plugging in all the numbers that I found in there. And I got this number right here because it's not shown in the formula up here, 172.34. I got this from the newtons with the friction equals the m and newtons, and it's 1.14 times 12.31. Now that happened like in the problem. I got the 12.31 from the newtons in the first place. I just did negative 981 minus 50 divided by 1/2 to equal 0, and they end up coming out to be newtons equals 1231 newtons, and that's how I got that. And then I had to get that number from these two to get this newtons. And then when I plug in all these numbers in my calculator, the final meters that they actually traveled is 7.49, and that's my reassessment for work energy.